Hi, we're looking at integration video series, video 7, and this time we're looking at volumes of revolution around the x-axis. Let's have a look at a key example for you. Okay, this question asks to find the volume of revolution when the line y equals 3x minus 2 is rotated around the x-axis from x equals 1 to x equals 2. Now y equals 3x minus 2 here has been drawn on this diagram and positioned here. And what happens is it gets rotated to form a bit of a, kind of like a half a cone there, or most of a cone. It's a bit hard to spot, but I'll try and draw a bit of an illustration of this. If you figure that that section of the line just here that goes down there is rotated around as if the hinge on it is on the x-axis, kind of rotating around this axis here, just this bit there, to create a bit like a witch's hat you might see on a football field. But it's the volume that we want to find. So can you imagine that rotating around and creating a 3D shape in here? Anyway, even if we can't picture it that well, we do have some guidelines from some formulas we can use to find the volume of revolution here. So the guideline, the formula we use is volume of revolution equals pi out the front, because revolution has things to do with circles, doesn't it? So integral of b to a, that's an a, of y squared. So we're going to have to get an expression for y squared to plug into this formula here, dx. So there's integration involved, and there's pi involved because it's a bit of a rotation. And okay, so that's what we'll be trying to use. Now, what we want to do is to rearrange this line equation here, y equals 3x minus 2, to get an expression for y squared out of that. Now, we've got a y equals expression already. If we square the left-hand side, we'd better square the right-hand side, and we'd better do it fairly carefully. So that's not too hard to turn a y expression into a y squared expression by just squaring both sides. And then that can take its place in the formula here as y squared. So instead of the y squared, we're going to put 3x minus 2 into our formula here to find the volume of revolution. So straight under here, let's just put a bit of a barrier here, and then we can head down here straight underneath our formula. Pi is going to be there. Now the question gives us the two x values that the rotation is happening between. So we've got 2 and 1 indicated there. Now y squared, instead of y squared, we're going to put 3x minus 2 all squared. That's the expression for y squared dx. And then we launch into an integration. So our volume will equal pi out the front. And then when we integrate 3x minus 2 squared, we add 1 to the power and divide by the new power. So we've got 3x minus 2 to the power of 3 divided by 3. And then you'll remember, because of our function of a function rule of integration, we must also divide by the differentiation of inside the brackets. In this case, it's 3. We do have a lot of 3's in this question, but still. So that's our expression for the integration of that. It involved the function of a function rule for integration. We did the usual integration bit about adding 1 to the power and dividing by the new power as well. But that'll be between 2 and 1. We'll keep pi out the front here for our calculations. We're going to sub 2 in wherever there's an x, and we're going to sub 1 in wherever there's an x, and subtract the 2 from each other. So when 2 goes in wherever there's an x, we get, I'll do it slowly, 3 times 2 minus 2 cubed over 9. And we can also put a big minus And 3 times 1 minus 2 cubed over 9. And see how that pans out when we do a bit more calculating. Now, 3 times 2 is 6, minus 2 is 4. 4 cubed, let's pop that in, 4 cubed over 9, minus, let's have a look up here, the 3 lots of 1 is 3, minus 2 is 1, minus 1 cubed over 9. That's supposed to be a square bracket there, that's not very straight, is it? But still, that's just a square bracket. So anyway, we end up with volume equal to 63 pi over 9, and 9 goes into 63, so that equals 7 pi. 7 pi units, but we're talking about a volume of revolution. So in this case, instead of square units, we have cubic units. 7 pi cubic units. So let's just recap. We took our line formula of y equals 3x minus 2. We squared that because we wanted to insert it here into this formula here as a y squared expression. Then we integrated, subbed in the x values of 2 and 1 that came from the question, and we basically processed our numbers through our volume of revolution formula, and just if you take care with the algebra, it should all work out quite nicely. I hope your working out's a bit neater than mine. That's a total mess, that bit there, but still. Anyway, I hope that helps and clarifies how you do volumes of revolution about the x-axis. Thank you.